And just like that, we are on episode 19. I'm Eric Knight, your host. Welcome back to the Rule Your Pool podcast. With me, as always, Jared Morgan. Jared.
Eric, thanks. Thanks for being here. Appreciate you being here.
Now you're thanking me. This is great. We're just going to keep going back and forth. In the last episode, we covered how to manage a liquid chlorine pool. And the episode before that was a salt chlorine generator pool. Now we're going to talk about Cal Hypo, calcium hypochlorite. And we're going to have to kind of divide this into two real categories because there's two very different types of Cal Hypo. Even though it's the same substance, they're used differently. Commercial pools use them very differently than residential pools. So Jared's going to tackle the residential side of it, and I'm going to talk about the commercial side of it. So let's just get right into it because we got a lot to cover. Episode 19 of the Rule Your Pool podcast. Let's go. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. All right, as we've started all of these chlorine episodes, just a word of caution. These chlorines do not play well with one another. Never mix two different types of chlorine together. It can be very volatile. The fumes can get you. It could also be an explosive risk. I guess just don't mix them. Rule of thumb. These are very volatile. And of all the chlorines, the most volatile is the one we're talking about today, and that's Cal Hypo. It happens to be one of the strongest forms of chlorine that you can put in your pool, but it also happens to be one of the most dangerous if you don't know what you're doing and you're not wearing protective gear and it's not stored in a well-ventilated area. So be very careful when you're handling this. So let's get into it. Cal Hypo, its proper name is calcium hypochlorite. When it's added to water, it will actually add a byproduct of calcium hardness to your pool. And that's about the rate of 4 parts per million per pound per 10,000 gallons. So it's a slight raise, but as Jared can attest on his own pool, because he uses Cal Hypo to supplement his chlorine, Jared, your calcium has climbed over the last 2 years, hasn't it?
Yeah, absolutely. And the reason is I know that it's going to climb. So in the wintertime right now, I supplement it with bleach and the rain dilutes it out. And I really don't start adding shock or anything until March, April. So I give it a chance to go back down. But I'm going to bottom out at around 400 and it's going to climb and rise throughout the winter and the fall and the early spring.
Okay, so you just said shock. What do you mean by shock? Tell the listeners.
Shock is, so we use granular Cal Hypo, and where I am in Texas, that's pretty predominant to shock or to superchlorinate a pool. And usually what that means is I take a 1 pound scoop or 2 pounds of shock in the bucket, mix it in, dilute it, and pour it around the perimeter of my pool in the water, of course, and brush it around to quote unquote shock or raise my chlorine level, from say 1 part to 5.
Well, there's other types of shock too. I mean, I know there's potassium monopersulfate, and that's a non-chlorine shock. People shock with dichlor, people shock with trichlor. You shock with Cal Hypo.
Yep. And it's just to raise the chlorine quickly.
Okay. So when you do that, what other than diluting it in a bucket, what other considerations does a listener need to take?
So what I do is you need to understand that the Cal Hypo has a pH of roughly 10.5 to 11. So higher. And that spike, just like with the other chlorine that we talked about, liquid, is going to temporarily increase the pH. And if it's a little more important on the Cal Hypo side is the calcium in there can precipitate and cloud the water, especially if the pH is too high. So acid's necessary.
Right. It is necessary on this. It's not as necessary on liquid chlorine, but it is necessary on this. And it's an LSI reason, right? Because over the course of a week, thanks to physics, that pH has risen. By the time you get back, now I'm not talking about your own pool because you can tend to it whenever, but on a weekly route, when you get back, the pH is usually around 8 if you're doing your job right. Well, that's a pretty high pH. Now, it's not high enough to precipitate all the calcium around, but when you add a high pH Cal Hypo to it, oftentimes what Jared's saying is exactly right. It will carbonate because it has a high pH of 10.5 to 11. Therefore, that is high enough to spike the pH locally and start precipitating as calcium carbonate, which is what clouds up your water. Very similar to throwing too much soda ash in a pool and starts clouding up the pool. Would you agree with that, Jared?
Yeah, and don't get me wrong, even if your pH is 7.6 and you perfectly balanced LSI water, when you initially add that Cal Hypo to a pool, locally when it goes in, it's still going to cloud. Doesn't matter what you do. It takes it a little bit of time of circulation and balancing for it to dissipate. So just know if your pool gets serviced on Tuesday, let's say, or you service your pool on Tuesday and you shock it with Cal Hypo, it's going to be cloudy for maybe a couple of hours during that time frame.
Mm-hmm. Well, that's if you don't lower the pH before you add the granular Cal Hypo. So if you lowered it before you actually added it, do you think it would still cloud as much?
It won't cloud as much, and it'll probably clear up quicker, but it's still going to be a little hazy.
But the habit is to actually add a little bit of acid after you add the chlorine. Is that what I'm hearing? I'm asking because I've never done it. I've never done this myself.
Yeah, you want to get the water LSI balanced and account for that pH rise before you add the Cal Hypo, because it'll make it stay in solution better. Not to say I'm perfect or everybody's perfect, because trust me, there's been many times when I've shocked a pool without doing anything with the pH and trying to chase my tail afterwards.
Mm-hmm. So what are some things to not do? All right, I'm a homeowner. I've never used this Cal Hypo stuff. You have a lot of experience on this. I don't. So this is a real question. What should I be avoiding?
Yeah, my experience is, 14, 15 years ago when I started servicing pools on a weekly basis, I was doing this exactly. And as a service guy, you're trying to limit the amount of visits to the backyard as much as possible. So you want to get there, do your job, and get out as quickly as you can so you can get on to the next job, especially if you have inclement weather or something going on that you need to kind of be in a hurry. Well, not proud, but we've learned a lot over the past 15 years. And quite honestly, I should have learned it at that time too, because it's not like this is new information. Mixing Cal Hypo with bicarb in a bucket and throwing my tabs right on top of that, because that's one trip. Boy, am I lucky. And I know I'm not the only one that's done this or does this, but absolutely don't do it, because if there's any moisture in that bucket, or if there's anything going on, any moisture on your hands, and you throw those tabs in that bucket and you start seeing smoke and heat and things like that, that's a very, very real possibility. And when we refer to unstabilized chlorine, Cal Hypo is unstabilized chlorine, just like liquid, but Cal Hypo's way more volatile and can absolutely create an explosion. So number one, don't mix things in the same bucket to reduce trips or convenience or whatever you want to call it. That's a problem waiting to happen. The second part is don't pour it directly into the skimmer. If you shock your pool and you're just pouring a scoop of Cal Hypo into the skimmer, you're putting that high pH directly into your plumbing lines, which is going to your pumps, filters, heaters. Everything is on the return and the equipment side, and you're circulating that water through. Well, let's say you have a pool that has a Trichlor feeder on it, and it's tied to your return line on the equipment. You pour a pound of Cal Hypo shock into your skimmer that goes directly through the return system, and you pump that through that Trichlor feeder, poof, it will blow up. We have seen pictures. You can look them up online. It is absolutely a possibility. So don't apply Cal Hypo directly to the skimmer, the shock. That's another very, very big thing to pay attention to.
Yeah, these chlorines are no joke. And I'm glad you're safe, but there's a lot of people that have made those mistakes before, and it's extremely dangerous. So we cannot stress that enough. Wear protective gear, store them separately, keep these chlorines well ventilated. Now, adding, if you had a bucket of sodium bicarb and putting something in bicarb is not nearly as volatile as chlorine on chlorine, but it's still not recommended because rule of thumb, never mix chemicals directly. Yeah, it's a bad habit. So in terms of residentially, you're using Cal Hypo granular once a week. You're really raising the chlorine level for the week, and then you come back and you just do it again. So on that, let's talk about strategy. how do you, as a weekly operator, where do you want to keep your pH? Where do you want to adjust your pH? Where do you want to have your alkalinity for that type of pool?
So I know we've said it many times, and I've told everybody I let my alkalinity drift down, and it pretty much regulates itself at 60 parts per million. And whenever I shock my pool, my pH will spike because I have an ORP sensor on there, and I can literally see the pH spike when I shock a pool. And all I do is just back that up with a little bit of acid to bring the pH back down into the 7-6 range so that it, can, number one, stay in solution. That's the goal here. But like we're saying before, doing this beforehand, before adding it, is a better option to keep it from clouding and staying too cloudy, because it's all about managing the LSI and keeping that calcium in solution.
And it's important to know that if you have lower alkalinity, just like we recommend on salt pools, just like we recommend on liquid chlorine pools, because again, the goal is to lower the pH ceiling of the natural rise over the course of a week. It's not to have as little alkalinity as possible. No, you still need alkalinity. You just don't want it to be too high. So you don't want to go over 80. What would you say, 60 to 80 for Cal Hypo?
Yeah, I mean, it depends on everybody's managing the pool. I mean, if they're going to shoot for those, pH numbers and alkalinity numbers in the textbook ranges, they're going to be fighting it a lot. And that's what we figured out, is we don't want to fight it. So that's why I maintain it at 60. And also it requires less acid to lower my pH if my alkalinity is at 60.
Well, your alkalinity fluctuates between 50 and 60 because sometimes it's 50, but when you do
it can go up to
drop
70.
test, when you do a drop test, it's either 50 or 60. So you're somewhere in there.
Yeah, it can go from 50 to 70, call it, but as long as I'm balancing it out with my pH, not taking my pH to 7.4 or 7.3, that's I don't do that.
That's huge. That's huge.
And like I said, pay attention. It requires less acid. When you run an alkalinity of 60, you do not need as much acid.
Yeah, use the Orenda app. It'll tell you exactly what your dose is based on your alkalinity. That's the correct way to do it. You need a lot less acid, and that actually ties really nicely into the commercial segment, which I want to cover here, and I'll get into that in a moment. But where should cyanuric acid be kept at?
Obviously, our company line is roughly 30 or less. That's plenty sufficient to offer UV protection and still keep it quick, faster.
Well, 30 is ideal. You can go higher.
Less than 50.
50 or less is really what we would say.
Yeah,
30 is ideal. Yeah.
Yeah.
Okay, cool. So is there anything else you want to add about the residential use of Cal Hypo before I cover commercial? Because I think commercial is a little bit more robust. It's a lot more popular in commercial.
Yeah, and just so you know, I supplement my Cal Hypo shocks throughout the week, which obviously I don't shock it every week. It's just when my chlorine gets low or whatever it may be, I'll shock it. And I use very minimal amount of tabs in my pool to keep my cyanuric down, but I'll say 1 or 2 tabs a week, especially during the summertime, is good enough, and everything else that's going on. But the one thing I will say when you're using Cal Hypo granular is do not just take your scoop or your bag or however you get it and throw it directly in the pool. Because if that goes on to the bottom, you're getting a local LSI violation on the positive side there on the floor.
It'll scale like crazy.
It will. So make sure you dilute it first. And if you do by chance pour it in. And
not just dilute, dissolve.
Yeah.
Dissolve it first.
A lot of times what will happen, like I said, service guy in a hurry, they'll dissolve it in the bucket and they'll pour it, but you'll get a few granules that fall on the ground. Make sure you brush those up, brush them around, make sure they don't just sit there because they will create issues in the future. And also, I did want to touch on one thing. There are Cal Hypo tabs for residential use, which I know that leads into what you're going to go into. But anytime we're talking tabs, in my opinion, I think in our opinion, with Eric, you would agree, it needs to have its own dedicated feeder.
Yep. That is a perfect segue into exactly what I want to talk about. Those tabs, they're pretty cool, but they are slower to dissolve. They are made in some senses to be put in floaters or skimmer baskets. And that's a type of that's a type of Cal Hypo that is actually made to be in a skimmer basket. You would never put trichlor in a skimmer basket. You would never put granular Cal Hypo in a skimmer basket. But those tabs are specifically made for that purpose. That's a bit of a difference. They're made for that. They're supposed to.
Slow dissolve and they're harder.
Yeah. Most Cal Hypo tabs are not slow dissolve. They dissolve very rapidly, and therefore they have specialized feeders. Now, As Jared mentioned earlier, there are trichlor feeders and there are Cal Hypo feeders, and you never, ever, 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 ever put a different type of chlorine than the specific type made for that feeder. If you put trichlor in a Cal Hypo feeder, bad news. And it's just as bad news putting Cal Hypo in a trichlor feeder. Now, in the commercial space, Cal Hypo is a lot more popular, in my experience. Now, you use it a lot in Texas. That's great. But around the country, Cal Hypo is used primarily as a supplemental shock granular on residential pools. But in commercial water, Cal Hypo comes in 3-inch tabs that look a lot like trichlor, but they're not. And
they're also a little different shapes. So
they come in briquettes as well. They come in little cubes. It depends on the brand, but they are rapidly dissolving and they are very popular in commercial pools, but they all have specialized feeders. Now, some feeders will hold a containment bin of briquettes or tabs, and then they'll spray water or flow water up from the bottom and just dissolve the bottom layer of those tabs. And then they have a little booster pump and they put that chlorine-rich water into circulation. A few key things to know about this. Number one, only that type of chlorine, as mentioned before, should be used in that feeder. You cannot use a competitor's brand and put it into another feeder because the ratios won't be right. It's not made for that and it's very dangerous. You could drastically over-chlorinate your pool. These are machines at the end of the day. They don't exactly know what you're doing in them. They're assuming you're following the instructions. Number two, the pH spike that will occur is temporary, but that doesn't necessarily translate to your controller. So if your chemical controller on a commercial pool, or I guess a fancy residential pool too, if it reads that high pH, it's a sense and dispense system that's going to tell the acid feeder to turn on. Here's the problem. That sense and dispense acid feeder and that controller do not have a mechanism for reading your alkalinity in real time. So unless you calibrate and tell it, every day what the alkalinity is, it doesn't know what your alkalinity is. And so it's going to base on whatever that was calibrated to. Let's say you told it had 90 alkalinity. Every time it feeds acid to correct whatever that pH is, it's going to assume you have 90 alkalinity and it's going to feed acid as if you have 90 alkalinity. That's a huge problem if you have 50 alkalinity. That's almost double the amount of acid, which of course takes your alkalinity way further down too. And it becomes this vicious cycle that's only going to be corrected at the expense of your cement surface because it's going to be etching to bring that calcium back up, which also brings your pH up. And as you can tell, you're just going to chug acid on these pools. We see it all the time. Now, of course, on a vinyl liner or a fiberglass pool, you don't have that etching capability, but let me tell you, it will degrade fiberglass. It will degrade vinyl liners. So these things will happen over time, and you have to be aware that your strategy for having a Cal Hypo pool needs to be based on a lower level of alkalinity by design. As we said in the last episode, if you're going to err when it comes to acid dosing, err low. Go lighter on acid than necessary if you're not quite sure. Go ahead, Jared.
Well, I think that's one of the benefits that comes with Cal Hypo in general is that when you're adding the acid and let's say you do have a feeder, it's not accounting for the alkalinity and it's burning it up as it's being injected. So your alkalinity is going to run lower. Well, the good thing about the Cal Hypo is that you're adding Cal Hypo at the same time. So it's causing the LSI to be higher. So you're kind of getting a trade-off there. So having higher calcium levels with a Cal Hypo pool is a good thing, especially if you have a acid feed. Mm-hmm. In my opinion.
Well, yes. And we deal with a lot of commercial pools at Orenda and a lot of commercial service companies. They really know what they're doing. They've been doing it a long time. But there's always those individual pools that maybe have not been calibrated right, or they have an operator that is full-time there that doesn't quite understand this. It's not an indictment on them. Most people don't understand this. Hell, we didn't understand this until not too long ago. So hear me out. You want to set your controller to a lower level of alkalinity. Potentially, I know this sounds crazy, potentially you want to set it to think that you have less alkalinity than you actually have. Again, I know that sounds crazy, but especially when you're dealing with something like Cal Hypo, you really want to make sure that you are not driving that alkalinity down too fast. Now, you do want to run a lower alkalinity, but you don't want to erase it. that can lead to huge problems. And you could get scale everywhere because of the rebound. So what I like to say is you want to set your parameters to correct your pH no lower than 7.5 or maybe 7.6. Now, I know some health codes say you need 7.4 to 7.6, but most of them will accept up to 7.8. I say you don't make a correction until you hit 7.8. You're going to use a lot less acid. And again, especially if you have cyanuric acid, it doesn't matter if you have a higher pH. I'm not advocating for putting a little bit of CYA in your indoor commercial pool if that's what you have, but it's a possibility. I mean, Richard Falk has written about it. You could. I'm not suggesting you do. I'm just saying there's different ways you can play this. What I am saying is the pH is supposed to rise through physics. It's going to happen. I don't care how good you are. I don't care how fancy your controller is. That pH is trying to rise because CO2 has to leave that water. It has to. The question is, how often are you adding acid when it does? Why not wait till it gets up to 7.8, tell the controller it has a lower alkalinity than it does, and gently bring it down? You're going to use a lot less acid, and you're running a much lower risk of a rebound. So contact us directly at Orenda. You can reach us through the app. You can email us, info@orendatech.com. Pretty easy to contact us. We're all over social media. If you are a commercial pool operator and you have a Cal Hypo feeder and you're wondering more about this on how to do it, call us, reach out. We'd love to walk you through it. It's pretty complex to put into a podcast form. And I think most of our listeners are probably homeowners, but it is important to know that you do have different parameters when it comes to a Cal Hypo pool. And because the LSI is so paramount, shameless plug, this is one of the first times we're actually going to talk about our own product here.
I agree. We haven't touched on our products per se in any of the specific episodes we've gone into.
It's an educational podcast, but this is worth sharing because of how Cal Hypo actually works and changes chemistry and it adds to your calcium hardness. You need some grace on the LSI unless you are exceptionally good at your job and you don't have unforeseen variables. But most pools do, especially outdoor pools. So SC1000, our product SC1000, that is a chelating agent that will chelate calcium and other metals. By chelating it, it prevents it from carbonating if the pH gets too high, say on an accidental rebound, or if the controller doesn't feed right or something like that. Or let's say you don't have a pH controller. Maybe it's a high-end residential pool that doesn't actually control based on the pH, it just reads it.
Or let's say you're there on Mondays and you're there once a week, and maybe next week you don't get there till Tuesday, and it gives you grace.
Mm-hmm. That's all it is. It gives you grace. That's a good way of putting it. It will take the edge off by making your water have a lot less available free calcium hardness to potentially carbonate into calcium carbonate. That could, potentially cloud up your water or form scale. So as Jared said, when he would come in and he would pre-dissolve his Cal Hypo, he'd put it in and it would cloud up the whole pool. That doesn't happen nearly as bad in an SC1000 treated pool because you have a chelating agent already in there. There's not as much free calcium hardness floating around. So it can't precipitate as rapidly. And if you have enough in there, theoretically, and the water's warm enough, it's not going to precipitate much at all. You could get away with not really clouding. I have an extreme example that I'll share, and I actually have this on a Facebook Live at a green pool cleanup. Jared, you might remember this. I had this digital pH probe, and I get out to this backyard pool, and it's totally green. I mean, this is a swamp pool. You can't see 6 inches into it. And, people always call us to their fun pools. The pH is off the charts on the Taylor kit. So I take this digital pH probe, and it's 10.4 pH. How did it get to 10.4 pH? Well, the pH ceiling normally is about 8.2, depending on your carbon and alkalinity. But this was a 10.4. And as I said before, carbon dioxide is trying to leave the pool only to equalize with the air above it. Well, what happens if you have an infestation of some substance that consumes carbon dioxide, like algae? Well, algae eats carbon dioxide. It's kind of like a plant. So it consumes it, therefore takes it out of solution. And because there's so much less carbon dioxide in solution at that point, the pH just goes up, 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 up. When I put in a Cal Hypo shock Jared, what do you think happened?
It clouded.
Oh, it didn't just cloud. All the calcium never went into solution at all. It floated to the top, and I had this big floating mass of white calcium that just stayed on the surface for 2 days. Never went in. And the cloudiness...
Lots of organics in that water.
Oh, it was disgusting, yeah. But the point is, the calcium separated right out. There was no way it was going into solution. Even as the chlorine was actively killing the algae, the calcium didn't go anywhere. It stayed on the surface. I've never seen a reaction like that except on that pool. I'm sure it would happen on another green pool too if the pH is high enough. So we could see these LSI violations in extreme circumstances with our eyes. In most circumstances, LSI violations are subtle. You don't catch them with your eye except over time. You don't see etching happen in real time, do you, Jared?
No, it's always a month or two later.
Right, and or maybe you feel it or something. The extremes, like this green pool example, where the Cal Hypo literally just didn't dissolve, or throwing soda ash into a pool, or Jared adding a whole bunch of Cal Hypo shock and it clouds up temporarily. Those are kind of the extremes, and SC1000 can definitely help with that because it chelates calcium to resist the, to hold it in solution and resist the opportunity to carbonate. So we've kind of gone around in circles a little bit here, but the point with Cal Hypo is it will temporarily raise your pH, but it's also raising your calcium hardness. So unlike liquid chlorine, you don't actually have to start with a higher level of calcium hardness like you would want to on a salt pool or a liquid chlorine pool. The reason for that is it's rising every time you add chlorine. So it will go up. Like on Jared's pool, he started at about 300. He's now over 500. But that happened very slowly. How many months? Over a year?
Yeah, it took a while to get up there. But like I said, I like to let it, I don't use it in the wintertime. So we get a lot of rain here and it dilutes out. And I'll end up probably around 400 at the start of the season. Then it'll build back up over 500 throughout the course of a season. Then I'll repeat.
Right. So
and constant backwashing and maintenance and doing the things that you're supposed to do to help dilute that water out is beneficial.
It is beneficial, but it's predictable. That's what we're getting at. Cal Hypo is a very predictable chlorine when it comes to the rate of increase of calcium. And you do want lower alkalinity, not necessarily as low as a salt pool, but 60 to 80 is pretty good because it will reduce the pH ceiling to resist scale formation. So that's really what we wanted to cover. Of course, cyanuric acid, stay 50 or below. If you're indoors, you're probably not using it anyway. But is there anything you want to add to this, Jared?
Yeah, I do get a lot of questions on when I say shock. Shock is a very misleading and confusing term that we throw around in our industry, especially in the retail segment. Homeowners will call me and I'll ask them, if they're trying to clean their pool up and dosing chemicals. I'll ask them if they shock their pool and they say yes. I say, what kind? And not everybody really knows what kind, because like Eric said before, there's dichlor,
it comes in a bucket, comes in a bag, yeah.
There's trichlor granular, there's Cal Hypo granular, and they're all three very different chemicals, but all of them come in this granular powder form that we use to shock our pools. So if you're going to shock your pool, make sure you're paying attention on the bag or the bucket or whatever it may be. It'll tell you calcium hypochlorite or trichlor or dichlor or whatever it may be. It'll tell you what kind of chlorine you're about to put in the pool. So pay attention to that, know which one you're using. That way you know how to prepare for that water after you add these chemicals. Be proactive. The other thing that I'll touch base on is temperature. The colder your water temperature, the more calcium is the easier calcium is to dissolve. So, when it's 60 degrees or less and you shock your pool with Cal Hypo, it's going to dissolve a lot quicker. You might not see the cloudiness and get into a routine. So make sure when the water's really hot.
Yeah, hold on. Yeah, no, you're right on half of it. The calcium does dissolve faster in cold water, but the chlorine doesn't. So the Cal Hypo, it looks like it's dissolving a lot faster in hot water because visually it will, but in reality, calcium does dissolve better in cold water. It stays in solution better. So you'll see a slower reaction in cold water up front, but there's two different things here. There's calcium and there's hypochlorite, right? The hypochlorite is the chlorine. The calcium is what dissolves faster. The hypochlorite dissolves slower. And so a little bit of a misnomer. I just wanted to clear that up.
Yeah, but mainly I'm just saying in the summertime, wherever you may live, it's not uncommon to have pool temperatures reach 95 degrees. If you're going to shock a pool with Cal Hypo in 95 degree water, you're going to have an LSI violation. It's going to be cloudy. Prepare for it.
Yep. It would make sense in that case to, before you add that, add your diluted acid to bring your pH down right before you shock. That'll help you avoid that. SC1000 will also help. Not that we really want to talk about product, but let's be honest, it's popular for a reason. It does really help with these sorts of things. So I want to wrap this up. This was by far and away the most in-depth episode of the 4. The next one's going to be about trichlor. This is the most complex. It's also arguably the most dangerous because it could be mishandled and there's so many different forms of it. Like a salt chlorine generator is pretty simple. It's a machine that generates chlorine. Liquid chlorine, that is what it is. Cal Hypo, there's like 6 or 7 different variations depending on the brand and
there's
everything has to be specific. Yeah, different strengths, different machines, different chlorinators, all sorts of stuff.
Yeah, you can go buy 54% Cal Hypo shock, and you can go next door and it'll be 74% Cal Hypo shock. So pay attention to your strengths.
Yes, absolutely. So that's all for now. This has been good. I've been looking forward to covering this one because we get a lot of questions about this. So this has been episode 19. If you have questions about Cal Hypo, or you look on that shock bag and it says calcium hypochlorite and you don't really know exactly how to use it, or you don't remember all of this stuff in the episode, just contact us directly through the Orenda app or on our website or on social media. We're pretty easy to find. If you have the Orenda app, right there in the main menu, you can just contact us, ask us anything. We love speaking with all customers, whether you're a homeowner or a service company, it doesn't matter to us. We love hearing from all of you. So thank you again for having us. My name is Eric Knight, your host. And Jared, you're just as much of a host as me. Who am I kidding? Jared Morgan, also with Orenda. Anything else before we sign off?
I think we got it. And like you said, if you need any help, reach out. Happy to help.
Very good. Thank you all so much for listening. In the next episode, the final episode of this 4-part series, we're going to cover trichlor. Take care. Hey, thanks so much for listening to Rule Your Pool. For more information on what we discussed in this week's episode, check out the links in the description or just visit our website, orendatech.com. I hope you found this podcast valuable enough that you tap that subscribe button and share it with your friends. With our help, you should be able to rule your pool in no time. See you next episode.